Defects of Rutherford model. This model suffers from two defects. First, regarding stability of atom. Electrons revolving around the nucleus have centripetal acceleration according to electrodynamics. Accelerated charged particles radiate energy, electromagnetic waves. Hence, electromagnetic waves should be continuously radiated by the revolving electrons. Due to this continuous loss of energy of the electrons, the radii of their orbit should be continuously decreasing, and ultimately the electrons should fall into the nucleus. Thus, atom cannot remain stable. Second, regarding explanation of line spectrum. In Rutherford's model, due to continuously changing radii of the circular orbits of electrons, the frequency of revolution of the electrons must also be changing. As a result, electrons will radiate electromagnetic waves of all frequencies, that is, the spectrum of these waves will be continuous in nature, but experimentally the atomic spectra are not continuous. Instead, they are line spectra, that is, they have many sharp lines, and each spectral line corresponds to a particular frequency. So an atom should radiate waves of some definite frequencies only, not of all frequencies. Thus, Rutherford model was unable to explain the line spectrum. These difficulties were solved by Niels Bohr with the help of quantum theory. Now let's see Bohr atomic model. Professor Niels Bohr removed the difficulties of Rutherford's atomic model by the application of Planck's quantum theory. For this, he proposed the following three postulates. First, electrons can revolve only in those orbits in which their angular momentum is an integral multiple of h upon 2 pi, where h is Planck's universal constant. If the mass of the electron be m and it is revolving with velocity v in an orbit of radius r, then its angular momentum will be mvr. According to Bohr's postulate, we have mvr equal to nh upon 2 pi, where n is an integer, n equal to 1, 2, 3, dot dot, and is called the principal quantum number of the orbit. Thus, according to Bohr's atomic model, electrons can revolve only in certain discrete orbits of definite radii, not in all. These are called stable orbits. Second, while revolving in stable orbits, the electrons do not radiate energy in spite of their acceleration towards the center of the orbit. Hence, the atom remains stable and is said to exist in a stationary state. Third, when the atom receives energy from outside, then one or more of its outer electrons leaves its orbit and goes to some higher orbit. This state of the atom is called excited state. The electron in the higher orbit stays only for 10 power minus 8 seconds and returns back to a lower orbit. While returning back, the electron radiates energy in the form of electromagnetic waves. If the energy of electron in the higher orbit be E2 and that in the lower orbit be E1, then the frequency nu of the radiated waves is given by h nu equal to E2 minus E1, or nu equal to E2 minus E1 upon h.